So as Olaf mentioned, we'll be doing a case study here with you today. So I just want to take a minute here to share what we're going to be covering today so you can decide for yourself if this presentation is for you. So let me start by saying that this is based on a project that Dylan and I worked together. And so we created this case study to show you a little bit of what happened and what we created out of that. So please don't get it confused with upgrades. The topic here is migration. There's nothing about upgrades here. I hope if you are interested in upgrades that you attended the session by Ed Hahn yesterday. So it's data migration, so how to bring data from external systems into Liferay. So here's the agenda. I'm going to start by asking you a quick question, and then Dylan will cover some common use case that calls for a data migration. And after that, we're going to dive into the case study, and I'm going to spend quite some time showing you some code for a migration tool that we developed together. And then just share some tips and tricks that we learned through that project, and the next steps for the migration tool we created. So, who here has never done a Liferay migration before? Good. So, I usually joke at the office that finding a project nowadays that doesn't require a data migration is like trying to find Wally. So it's pretty hard. Like we've done I don't know how many projects in the past couple of years, and all of them required a data migration. So with that, Dylan will cover some of the common use cases we have for data migrations.
Yep. Thanks, Igor. So when you think about a migration, that implies that you have data somewhere and you're moving it to a new location. And the question before we even talk about migrations is that necessary? Do you really need to do that? It's often better to keep the data where it is if you're able, access it, pull in only the information you need when you need it. That way you don't have to worry about storing it, you don't have to worry about replicating the data, you don't have to worry about the data retention policies or anything of that nature. However, there are some cases where that isn't available, that's not possible to do. So looking at some of those, one of them may be replacing an old system that isn't related to Liferay whatsoever. It's a different platform. Maybe you need to move documents over from it, such as like a SharePoint or that. So you're replacing what already exists. So because you're replacing it, you have to actually move those over. Another use case may be moving over a static site, a custom site that exists in another space. It's being deprecated or replaced with a better tool. That may be moving over that static content into Liferay, making it web content so it's searchable or anything like that. And then a little bit more in line of what we'll be talking about is actually moving over, rather than information and that, moving over data itself. So whether that's pulling in from web services, whether that's pulling in from different database tables and that. So you're working with an external system, moving that data over into yours for different reasons. One of them may be you have an LDAP server that's pulling in user information, but you don't have a complete profile from that. So you're going to pull over information from an external HR system or whatever it is, build that complete information from that. And with that, there can be some limitations that you have to overcome, which is the situation we ran into. So before we look into the tool, before Igor goes into that, I want to give you guys a little bit of the story that we experienced. And so the project that we worked on was it was for a large financial institution in the United States, and it was a self-service portal, so that the customers were meant to, or the employees were meant to come to this, helps answer the questions, helps them to find different information they needed. And our problem was we had to pull in substantial information, or I guess use an external system that had substantial information we needed for different business processes, whether that's with workflows, whether that's again with user profile information. And we said, okay, that's not a problem. We do external integrations all the time. And then they come back to us and say, oh, and the system, you only get 5 connections to it. And we say, okay, that could be a problem. So we're like, and we needed this for doing different types of searching in that. And even with 0.5% of the intended concurrent users, that would saturate that 5-user connection pool. So we said, okay, we need to pull in this data. Not a problem. We'll build a simple solution for that, pull that in. We quickly found out that the table, the amount of data there was several magnitudes larger than we had expected. Ended up being several million records. And the very simple serial sync we made took roughly 8 days to complete, if it ever completed, which was a problem, especially because we intended to sync this once every 24 hours. So another issue we ran into it when we initially built it was because there was so much data, if there was an issue with one, it would fail the sync, which would require us then to resync the entire 8 days. And one final issue was because there was so much data, we would enter their transactional layer once, we would start pulling the records, and it was trying to build a transaction so it could roll back, which then caused memory overflows to happen. So with all these different issues in mind, we obviously had to figure out how to reduce the size, or reduce the time it took to do this sync, figure out how to stop the memory overflows from happening. We had to sort of compartmentalize and fix that issue. And we had to, reduce the time. And we actually ended up reducing this 8-day sync down into about 3 hours. And Igor will go ahead and tell you guys about the tool and sort of what that looks like and how we did that.
So as Dylan mentioned, we were like in a time crunch. We needed to get that migration done, and we just had a week to develop this. We had to bring it down to a couple of hours. Otherwise, it would just compromise the launch of the new system. So we started developing this tool. And again, as I said, we had done this before, like for many other projects. And this time we decided, okay, let's try to extract this code and actually build this tool so we can keep using again and again, because it's a very common use case, and the code is pretty simple. It's just transforming data from one format to the other, and the framework that we built actually just provides a way for you to run those things in parallel. So that's the idea. So you develop your business code, and we provide the framework just to run that concurrently. So just to give you the basics of the tool, it starts with a scheduled job. So that scheduled job triggers the data sync, the executor. We created a very simple entity relationship model to store the statistics about the migration. So extremely simple. So every time we run a migration execution, at the end it stores on a table called migration. How long it took, how many records it migrated. So very simple relational model. The other main key component of this, we implemented in the XP this time, so we could leverage all the nice things about OSGI. So we are using OSGI services to inject all the classes that transform the data. So every time, let's say you're migrating 7 tables, or 7, let's say, data source. It could be a web service or something like that. And tomorrow you have to add one more. So you just go implement a new class that extends an interface that we defined, deploy that module, the migration will pick it up and use that as well. So it's just a simple dynamic injection that we do. And last but not least, we do the concurrency part, and basically, and I'll show that in the code. There's 2 points that we do the concurrency. We trigger one thread for each one of the entities that we want to migrate, each one of the services, and then within that thread, we open multiple threads to migrate the data in batches. So we provide you ways to define the size of the batch, so you can configure that. You can also configure the thread pool size, and with those parameters, the tool just executes the migration for you. So let me show you. I'm going to switch back to a diagram I have online that is probably better to see this. So I created like a sequence diagram here just to explain that code. And keep in mind, we did that code as this is the first version of that tool. So it's kind of like we refactored the code to be able to introduce the concurrency. So the architecture is still not, ideal. We're working on the second version of this tool. So what you are seeing here today is just, like the first version that we did for that very specific project. But as I mentioned, we have a scheduler at the very beginning. That scheduler triggers the migration execution, which is the second component. That migration executor, it's listening for new migration services from the OSGI registry. So it's pretty much listening to that. And then once you deploy modules with migration services, what it does is it kicks off the migration service. And that migration service is pretty much the controller and the transactional boundary. So the yellow box that you see there, that's a service builder component. So all the transactions are controlled by that guy. And what we did, things go back and forth on that guy because it's controlling all the transaction. And this way we were able to solve most of the transactional issues that we were having with that client. So the migration service creates migration tasks. Each one of those tasks, as I mentioned, it's a separate thread. And then that thread will open multiple sub-threads for each one of the batches. And the last box that you're seeing there, the blue box, that's all you have to do to migrate your code. That's the business logic. So you're going to create multiple components that implement that interface. And pretty much that interface is very simple. You have to provide two methods. How do you read a batch? So it could be, let's say, it could be a web service. So you have a read batch, and then you call a web service, get that batch back, and in return. And the second method is just how do you save that? So pretty much how do you read and how do you save? That's all you need to do. So with that, I just want to show you, some of the code just to make this a little bit more, concrete. So let me switch back to my IDE here. How is the font size in the back? Can you guys see from the back? Is it good? Okay. So here on the left, let me move here a little bit. So we created this tool using the Liferay Workspace. You probably saw some talks about this. Greg had some talks on that tool. So we have a Liferay Workspace, and we have pretty much like 3 modules that compose the migration tool. So we have a data migration API. We have the data migration service that implements that API. And we have the scheduler. So the scheduler module is just, just the scheduler itself kicking off the migration. So it's just one client of that API. So let's say if you want to trigger the migration from the console or from the scripting executor, you can even create like a Google Shell command and to trigger the migration and use the same API. In our case, we have the scheduler. And then let me show you some of the main services. But as I mentioned before, the only guy that you have to worry about implementing is this entity service. So here's the trigger point for us. We have the listener, the scheduler. It receives a message, and then it will kick off the executor. And then the executor, it has a bunch of entity services. And the key point here that I mentioned before, we are using the OSGI injection here. So we are using the Clarity services here. And as you can see here, it's multiple cardinality. So it means every time you deploy one more component implementing this interface here called entity services, I will get a new component in this list. And then next time the scheduler triggers the migration, it will grab all those components and execute each one of those in a separate thread. So this is the main method that triggers the migration, migrate all entities. So I'm using a fork join pool here. We tested a bunch of different executors. And for Java 8, we had very good results using the fork join pool. But our idea is to extract this as well, so you guys can replace this. But we pretty much submit one of those services. As you can see here, the migration service, just kicks off the migration of the entities, right? And then let me show you this guy here real quick. So this guy here is the transactional boundary. I have the migrate entities method here, controlling the migration of all entities. I'll show you real quick the migration. So that guy creates an entity migration task. And each one of those tasks will migrate all the data related to that entity type in batches. And again, you can define the size of the batch. I keep saying entity. I'm using the service builder nomenclature here, but it doesn't have to be a service builder migration. It could be, again, a web service. As long as you implement the entity service interface, you can bring the data from whatever you wanna bring it. We do use service builder internally just to save the stats of the migration tool. So let me show you one more component here, which is the batch executor. So this is the guy that is actually doing the migration. So executing the batch. And most of the parameters that we have is to define these things here on the thread pool executor. So, the pool size, all those things we have right now. We're still using portal properties for this, but one of the things we're gonna do in the second version is start using OSGI configuration, so you guys can change those things on the fly. So, and then you can resize the pool without having to restart the server. So, but that's it. I just wanted to, give you a quick overview. We're gonna make this code available on GitHub for you guys to, to try on your own. We do have a sample code here to show how to use the tool, the migration sample. And in this case here, we are just migrating, creating Liferay users. So we are calling a web service from WeDeploy, and then we grab the information that we need to create a user and create 100,000 users in the Liferay database. It's a very good use case because creating a user takes quite a bit of time. So it's a good exercise and sample for you to explore the code. So Dylan will go over some of the lessons learned. Sorry for the technical difficulties.
Yeah, sorry about that, guys. But I think one of the cool things about this tool is we didn't go into this project, I guess, or go into this development with the intent of making this tool. Again, it sort of organically grew out of the problems we had. And yeah, from that we are able to build this, and we hope that it's obviously useful for more than just this. And at the very least, these are some of the lessons we learned, and hopefully these are useful for you guys in your migrations as well. But one of the key things is, which hopefully is obviously, but pull exactly what you need. Only migrate what you're going to use. And there may be some benefit of adding a little bit more fields or information here or there in case you might use it, but in general, try to limit the data you're pulling, whether that's different types of tables that you're pulling, whether that's columns in those tables. one of the tables we pulled actually had ended up having 300 columns in it, which we knew going before, but then we actually got down to the requirements. They're like, oh yeah, we actually only need 10 of those maybe. So being able to trim some of that out. They also had, they never cleaned up the tables. So they had 700,000 entries in one of these tables, and we only needed maybe 20% of that. And there was a very easy flag we could distinguish the rows from, but we had to actually dig down into that to figure that out. So being able to reduce the data size is very important. It helps you reduce your overhead, helps you reduce the storage in general. The other thing is when you're dealing with data this large, it's very important to try to, where possible, distinguish the migrations. So while this migration tool will migrate everything, it's handling them sort of compartmentalized. So each entity type, whether they're users or locations or addresses, each one of those is, they're migrated independently so that if one of them has issues, if one of them ends up failing, if one of them takes longer, it's not going to affect the other one. So that they can complete independently so that you don't have to keep restarting the entire sync, but more importantly too, it helps you keep the transaction overall size smaller so that you don't have one massive transaction managing the entire migration where you get the memory overflows and such. It helps reduce that size. The other thing is with migrations of this nature, again, it's important to really tune the size of, if you're doing batches, your batches, if you're doing, well, I guess just in general, tuning how many threads you have running it with this tool, tuning the size of the batches you're pulling in, that you're writing to the database, making sure that they're manageable, but also making sure that you're pulling fast enough where you can write and you're not having threads waiting, but also you're not pulling too fast where you have lots of threads waiting for CPU time. So trying to find that tuning balance is important as well. And one of the things Igor mentioned, though, that our tool has is a simple way to sort of start one single method call to start this sync. And why we find that helpful is so that you can trigger it multiple different ways. We do have the automatic scheduler, which will do it on a timely basis, but at the same time, there were times where I needed to do it manually so I could debug through different things, and being able to do that in DXP or in Liferay 7, they have a scripting executor where you can just execute code from the control panel. So as an administrator, I was able to go in there, start the sync, be able to do some diagnostics and actually see what's happening. I didn't have to redeploy code and tell the listener to trigger like every minute or whatever to actually get it to happen. And really the last thing is keeping stats or logs of what's happening is very important. In the tool, we have several different log levels. It tells you when entities started to sync, how many of them they synced, the overall times. We also have that stored in the database, and you can do simple data reports to get that information. So for every entity, it saves information, and then for the sync overall, it saves that information.
Okay.
And the other thing with this tool is we want it to be, if our lessons learned is all you want and you want to use that, that's cool. But at the same time, we want it to be able to be helpful for the general audience too. So we're actually planning on continuing to develop this tool. We're making it available in a public GitHub too. And again, we want it to be helpful. So some of the things we're working on to improve it is, like Igor said, we're moving over to OSGI configurations, so you can change the batch size, the number of threads, all of those from the front in the control panel rather than having to change it in the portal properties, so it helps you speed up your tuning for that. We're also adding we plan to add a control panel portlet or a view for those data statistics, so you don't have to actually go into the database and do data reports to see those. Having a tool to aggregate those and make those searchable, make those very easy to see, so you can, again, manage this a little better. And the one final thing is, which Igor will describe, is actually changing the model to be a little more efficient.
Yeah, so for just to conclude here, for the next version, we are working on a different design that we use a producer and consumer architecture. So the idea is you're going to be able to configure how many producers you want to open to read the data and consumers to save the data. What we notice, what happens sometimes, the read can be slow, but the save can be very fast. So we want to make sure that we can give you that ability to tune how many producers and consumers that you have. So that's the architecture we're going towards. As I said again, the code will be available on GitHub, and we would be happy to get collaborators and feedback. That's it. Thank you for coming, and there's the link.